mixed panel now with VC and Pedro. Unfortunately, Arjun, who was supposed to join, he's got a really bad cold. Actually, I think there's a super cold going around at the moment that isn't COVID, because I read that on the BBC. And so everyone's getting sick with fresh or flu. And I think he's probably caught it. So, you know, that's this life. So we'll welcome on Pedro and VC. I say VC because I find it really difficult to say his name. So hopefully you can pronounce it for us and then I can copy it. So do you both want to introduce yourselves first before we start, you know, talking about the liquidity providers and Synchrony? Oh, I can't hear you, Pedro. Your audio doesn't work. Ah, we nearly got away with this session with no audio problems. VC, do you want to go first while Pedro works on his audio?
Yeah, sure thing. Thanks for having me here. My name is a bit difficult to pronounce, so I'll do that first. I'm called Vaibhav Chellani, and that's VC for short. So you guys can call me VC, but like I'm definitely not a actual VC. So like I have some like history working with layer 2 systems. I was at Matic before. I was doing a lot of plasma research there. Then I built a ZK rollup with Barry Whitehat. Then I was at Ethereum Foundation building an optimistic rollup called Hubble, which kind of uses BLS signatures to compress the on-chain data. During my time there, I started like fiddling around with moving masses of users from one L2 to another, and that kind of started me on this like how do I make cross L2 communication better journey.
Can you hear now? Perfect. So hello everybody, thanks for having me here. My name is Pedro Moreno-Sanchez and I'm currently an assistant professor in IMDEA Software Institute. And yeah, so I started with this looking at the privacy of Bitcoin, and I saw how all this started with the Lightning Network and these layer 2 scalability solutions based on payment channels that Patrick was presenting before. And yeah, so there I'm interested on basically on the cryptographic operations that we use in order to have the properties like atomicity and privacy. And recently I'm interested on two main ideas. So one is the interoperability or basically the interconnection between all these systems that we are seeing, because right now they're pretty cool, but they seems like they're isolated silos or isolated islands, and we will need a way to connect between each other. And second, I'm also interested on looking at what is the privacy level that we have in these systems. Like, you know, like Bitcoin appeared, there were really a lot of works that looked at what was the privacy losses that we had, or what was the anonymity problems that we had with them. And now we are in this layer 2. It seems that it's time actually to pay attention of, you know, analyzing and defining what privacy losses we get and how we can actually improve this system to get even better privacy guarantees.
Awesome. So let's start off with the first topical point. I guess this feels more like a podcast now, but we're going to talk. I just asked a question about Twitter in El Salvador. So for anyone who hasn't been watching the cryptocurrency space, El Salvador made Bitcoin legal tender, and their whole dream is to have the Lightning Network facilitate payments in their country. So you can go to Starbucks now and you can buy your coffee using Lightning, and that does actually work because there's videos online about it. And Twitter now supports tipping, so you can tip people via Lightning as well. And so I guess it's mostly directed to Pedro, but you know, VC, you can also just jump in. How do you feel about the news that you can tip people using Lightning on Twitter now, and it's actually natively supported on El Salvador? What's your opinion on that so far?
I think it's fantastic actually that we see these technologies actually being deployed in practice. I think that the first papers about it appeared in 2017, 2018, and it has been really a lot of academic work behind these systems. Also, of course, a lot of industry work around that. So I think it's really nice actually that after 2-3 years, that not only there is a lot of adoptions from the cryptocurrency community, but also like in real life scenarios. And also actually give us a new use case or new scenarios where we will learn a lot about what can go good and what can go wrong actually in real use cases, or use cases that are not artificial or thought for experiment, but is really that people really using for the daily life. So I definitely like a really good experiment or use case to learn from. Mm-hmm.
Yeah, definitely extremely happy to see, L2 adoption booming in all of these chains. And more importantly, definitely really excited to see what are the actual practical problems that, come up when a large mass of people start using these systems, and all of our theoretical assumptions are proven right or wrong,
Awesome. So my question was, this one's for Lightning, and I sort of what's the best way to describe it? So there was this video put online by LN Strike, and they were sending funds in the video to someone, and then someone found the transaction hash on Bitcoin, and they realized that the payment wasn't actually sent via Lightning. It was someone withdrawing from an ATM machine. And that withdrawal transaction actually sent a Lightning on-chain transaction to pay for it. And so what's quite interesting there is that sort of highlights one of the routing issues, and also sort of the liquidity issues that pop up with these payment channels. There's not enough outbound capacity somewhere, then you physically can't send that over Lightning. So I guess this is for Pedro. Can you provide any insight to sort of the routing issues that pop up, and ways that people are trying to get around these inbound and outbound capacity issues? Maybe like, I don't know, like the Revive protocol and stuff like that. Do you have any insight around how people deal with this issue?
Right, this is really a really challenging problem indeed, and one that we have in practice a lot. So basically, to put a bit of context, the problem is, as you mentioned also in your talk before, is that if I create a channel with Patrick and I put myself 6 coins, let's say Bitcoins, I can use this channel only up to 6 Bitcoins, and I can, at the beginning, I can even use it only in the direction from me to Patrick until I pay some money, and then he can actually pay me back. And if I want to pay with somebody else, either I create another channel with him or with her, and then I have to put even more money on top of it, or rely on all the friends or other channels that Patrick has to route through him. And this actually opens the problem of how do I find a possible path between myself and the person I want to pay to. And it's not so easy. Of course, if you think of it of a graph, you need to find a path of between two nodes. But here, the fact that we are dealing with payments and with money actually adds extra restrictions. Like a path is not only valid it's not only valid if it exists, but it has to have enough liquidity. So what's happening in practice, or we have seen it in the Lightning Network, is that the networks are conforming this more like hub and spoke, like really nodes really well connected that are actually having a lot of channels and providing liquidity for the rest of the networks. And system like this Lightning Network, that in principle you can have payments for up to 20 hops, I think, or 15 to 20 hops. In practice, is really just 4 or 5 hops, because having more it really consumes a lot of liquidity. So things that I have seen actually happening recently is that using payments where you don't use only one path, but use several paths, so that basically you distribute the charge, or distribute the force and liquidity among several users or several paths itself. So this is one of the options. And the other is that once the channels are not liquid anymore, meaning that all the coins are in one side of the channels and you cannot use it in the other direction, then there are approaches that have been defining in terms of rebalancing, which means that a group of friends gather together, they say, look, our channels are balanced in only one direction, so let's agree on rebalancing all together, which in practice means like creating a circular transaction that that rebalance the channel, or basically the balance at each of the channels of the path. So these are the two constructions I have seen that mostly that have been proposed, and also kind of implemented in practice as well.
Awesome. VC, do you want to add anything, or was that enough? Cool. And also, just to the audience, I mean, if you want to ask questions like Sergey has, and I'll answer that, and I'll ask that in a second, just drop a question in the Q&A and we'll ask it in about a couple of minutes. So the next question I have, and this is sort of moving away from Lightning a little bit, it's mostly what VC is working on, is one of the reasons why I wanted them on the panel. Is basically the problem you're solving is you have two off-chain systems. They could be custodial wallets, or they could be roll-ups. We don't care. There's just off-chain systems, and you're providing a way to move funds from one chain to another. So one would be you're on optimism, you want to move funds to L1, you want to do that very quickly. But you're not using channels for that. So what are you doing? Like, how does it work? Maybe give a little overview of, how your protocol works and even what it's called. I don't want to spoil the name for it.
Yeah, so like the protocol is called Mover, which is like basically trying to help people move assets and state from one chain to another. And like let's maybe talk about rollups today. So like say there is a user on Optimism that wants to withdraw some funds to layer 1. Yeah. The cool thing about rollups is they achieve finality as soon as the transaction data is made available. So as soon as the rollup sequencer posts the transaction on chain, off-chain participant can know, okay, so the funds are in the withdraw queue and they cannot be rolled back if the L2 state is valid. So the off-chain participant now can get into a 1:1 agreement with the user saying, hey, I'll give you funds on layer 1 itself, and after 7 days when your funds finalize on layer 1 and I'm allowed to withdraw from the L2, I'll take back the funds that I gave you on L1 along with like a convenience fee of sorts. So we basically like try to bypass the slow withdrawal mechanism that L2 offers natively by using external market makers. I think I would like describe it that way. Patrick, do you want to add any more color to it?
I mean, I called them liquidity providers before, people who just have money on it, on a block, on a network, or they have money on a system and they're willing to front you the money very quickly.
Yeah, solid one. Yeah, so like anyone who is like observing the roll-up state and knows that once like the transaction that are just posted on chain won't roll back, can provide the liquidity to you on the destination chain and can take back the liquidity from you when it finally arrives through via the slow mode.
Awesome. So like one question there is, like, what are the trust assumptions around it and who can actually front the money? Will it be like a little decentralized pot of people who just take a job and send it? Or will it be a central entity? And like, how does collateral work there? How do you make sure you have enough funds on one of the chains?
Mm-hmm. So yeah, let's maybe talk about how will the liquidity provider market work. So essentially, like theoretically, everyone can observe the roll-up state and can know if the withdrawal that I'm providing the liquidity for is valid or not. But there is like a race condition here where there is one guy who wants to take 100 DAI from L2 to L1, and there are like 50 liquidity providers who want to kind of provide front the liquidity for it. So there likely will be like a central coordinating mechanism so that people don't lose money trying to front run each other. But apart from that, the process should be like pretty much permissionless. What was the second question, Patrick? Do you mind going over that again?
Just the collateral as well. Although one thing I was thinking of, if you didn't want a central coordinator, I mean, we could talk about that. That's different. Okay. Yeah. What about the collateral limits? How do you deal with the like, I don't know, like, is there like a transfer limit, for example? Is there inbound, outbound capacity issues? Or,
yeah.
And can I donate, like, can I add to a pool for this? Can I do it passively or do I have to be active?
Yeah. So like, so there are some like current designs. So like the most simplest design would be there is a single guy using his own liquidity to kind of front you liquidity on layer 1. But the problem here is similar to I think what channels have, because like once if I have like $1 million and I have fronted that $1 million, then I have to wait for those withdrawals that I have fronted liquidity for to actually come through to free up my liquidity so that I can use the funds again. So like there are some liquidity constraints here, and I'm a single guy providing liquidity, so I can't expect users to just like give me liquidity and I'll promise to kind of fund only valid withdrawals. So like there is like a liquidity scaling issue here. There are some designs that I'm working for with Mover where maybe we can like decentralize this aspect of third-party liquidity providers so that passive liquidity providers like you and me can just deposit money into a smart contract and trust a group of people to add, allocate that money only to valid withdrawals. So like there are like several models to scale the liquidity here, but like there are like upper bounds to this definitely.
Awesome. So I'm going to answer two questions, or not answer, I'm going to ask two questions from the audience. And if anyone else has a question, just drop it in the chat and we'll get through your questions. So this one's from Sergey, and he's basically asking, the number of nodes and channels in the Lightning Network seem to have growing exponentially. At last, all the excitement is that it's finally growing. Do you think this is a direct consequence of the El Salvador experiment, or can it be explained by other factors?
Yeah, I mean, definitely, I think that there's a fact that there have been, these real life use cases for things like channels. So Lightning Network definitely helps to attract more, to gain traction, like, to attract more and more users. It's also true that this happened only recently, and the growth of the number of channels in the Lightning Network, for example, has been steadily growing over the past years. I mean, past month and even the past year, and even before actually these events happened. So I think, just to be concise, yes, I think of course helps to to get the people know these technologies and get more traction. But there have been also even people using it beforehand, before that.
Awesome. And this one's by Denise. Maybe do you want to ask us? You're just a panelist anyway. You could just ask your question.
Yeah, I was wondering about the liquidity upfront, the upfront liquidity providers for optimistic rollups, and you said that you can do that for fungible coins like ERC20s, where the liquidity provider can check to see if the money is really yours, and then give you the equivalent amount or a little bit less upfront. But can you do the same for NFTs or non-fungible tokens, where you really, due to the non-fungibility of this, there seems to be no easy way for a liquidity provider to give you your NFT before the dispute period has expired. So is it really impossible, or what are your comments on that?
Yeah, so like that it is true that when we move beyond ERC20s or non-fungible stuff, things start becoming a little bit difficult. But let me post something on the chat here. I don't know if everyone can see this, but like this was a proposal by Vitalik that kind of allows people to mint a wrapper NFT on the destination chain, and people who are validating both chains can kind of use the secondary or the wrapped version of the NFT, considering it to be valid post the destination, post the finality period of the sending site. So like there are these like several other schemes using which we can transfer state from one L2 to another L2 and kind of bypass that dispute period. But those are definitely more complicated than ERC20 or Ethereum based use cases.
For the Vitalik scheme, do you want to give an overview of it? Like, is there some trusted committee in there, or is it just I'll have to give an overview. If you can't give an overview, I don't know.
Yeah, so like so there are like two things here. Any external party who is like validating both chains will know instantly if the wrapper NFT is valid or not. So, but like just how things work in the world, people would likely want this validation to be outsourced to a external bonded actor. Yeah, and the actor here can be a large set of large set of attesters that are continuously validating both chains, and they kind of provide you economic guarantees that okay, this is a wrapper that I created based on a withdrawal wrapper here. You can go ahead and verify it yourself, or you can post a challenge to my attestation if I'm kind of lying. It's a like pretty broad research space, and something that I'm actively working on. Like my core interest actually lies on like getting smart contracts on two different L2s, trying to communicate with each other without going via the dispute period of the L2 itself.
I think that's a great next question then, because I've been thinking about this myself. So basically the problem is you have two off-chain systems, and there's a smart contract here and a smart contract here. Let's say, I don't know, there's Uniswap and SushiSwap, and you want to have some arbitrage opportunity Right now on Ethereum, the two contracts are on the same system. You send a transaction, it does the swap, it passes or it fails, it's composable, it's atomic. But now if they're on different systems, like how can you reintroduce composability there such that if I send a transaction on Uniswap, it should only execute if my swap on SushiSwap executed as well? And have you guys given any? So for me, I think the obvious solution to that is using HTLCs or some variant of a conditional transfer. But have you given any thought to that sort of problem and how that might be solved? Basically creating atomic transactions that occur across different off-chain systems.
Yeah. So like arbitrage is a really interesting use case, and dexes are significantly harder to do like cross-chain stuff with because like price varies a lot. For arbitrage actors, I think the best approach for them is going to be to not use any bridges at all and only use the bridges to rebalance the funds and not to catch any arbitrage opportunities. So they would like have inventory on both chains, and they would run like a system in between that kind of helps them coordinate this stuff, because like any kind of bridge that you use is limited by the source chain's finality. And in a roll-up world, that's going to be the time it takes for the transactions to be posted on layer 1 and the time it takes for the layer 1 to kind of get 6 to 12 confirmations on it. So like for any kind of arbitrage opportunity is going to disappear in that amount of period. So like the best case for arbitragers is like have inventory on both sides and kind of rebalance using these bridges. On the atomicity front, definitely using HTLCs is like the fastest atomicity guarantee that you can have. We can have atomicity by other ways, but they definitely won't be as fast as HTLCs.
Also,
yeah, maybe just a point actually to follow up on this point. That I think atomicity using something like HTLC, of course, is, I mean, we have learned from other systems actually is fast and works. But I think one challenge that we might get in this type of scenarios is that each of these layer 2 will have their own parameters. In particular, for example, their own timeouts. I mean, we have seen before the discussion about whether we should use 7 days or 3 days, or what is the parameter for that. So I think the coordination of even a simple the coordination of the setting the parameters among the different systems for a simple coordination mechanism as the HTLC is not trivial. Because, like if my time expiration in one system is let's say 1 day and the other 7 days, what does it mean, like atomicity then, for example, in such a case? So I think really like atomicity in this layer 2 setting is actually challenging when you really talk about systems that may not even know how the other is even set up. So we might even see like probably get into a set of players that run a committee and they have to agree in the majority of them. So there's I'm not saying it's impossible. There might be possible solutions to it, but not as trivial as it seems at the first place, indeed.
Awesome. So, I mean, we only have a few minutes left now. So I'm just going to finish off by asking you guys, this is a room full of PhD students and faculty and academics who like juicy research problems. What do you think is like the most interesting problems at the moment based on what you're working on? If you were going to tell a PhD student to go work on a project for 6 months, what would it be?
So I think from my side, actually, one really interesting one is how do we find players, or how do we connect these systems, right? As you mentioned, like we will have many of these layer 2, and I will have coins in rollup 1, and you, Patrick, will have in rollup 2, and I want to pay to you. How do I find a possible chain of systems that I can connect to, and that there is liquidity and that is atomic and so on? So basically, I think this interoperability, or finding possible routes, or finding the networking of these systems, is definitely something that it appears more to me that more and more than actually would be needed in the next phase. So this is one, and the second, as I mentioned at the beginning, I think of course we are building many systems, and privacy is always left as the second player. But it would be good to start thinking about what modifications we can do actually to the system that we have, such that we can achieve better privacy guarantees, or even define what we get and see if actually they're enough. have a framework where we can actually discuss what we get and what can we get more or less. Actually. I think this will be the two ideas I will be super interested in the future.
Mm-hmm. Yeah, adding yeah, those are some like really neat ideas actually. I'll just add like two more of mine to those. So like we are kind of moving to a synchronous smart contract communication model, and I haven't seen a lot of people trying to build programming frameworks around it in like a blockchain context, and like that's something very exciting and user facing, and something that we need to solve in the near future. The second would be if we wanted to kind of put a dollar amount to a state variable, how would you want to go about it? So like, let's say how you quantify the upper bound to a ENS name, for example. If we get like a answer to that, then that would help with a lot of MEV related problems, and as well as having trustless cross-chain communication via bonded committees. So
awesome. I mean, we don't actually get to talk about MEV here, which is a shame for the first L2 workshop I've been to that didn't discuss the MEV. So thank you very much, guys, for taking part in the panel, and thank you everyone for staying for the full 2 hours and listening to us talk about it. So I'll hand it back over to Fatini now.